point of a to b, on closed interval a to b, and if f is any antiderivative of f on a to b, then a to b f of x dx equals f of b minus f of a. Notice I used a capital F to identify it's an antiderivative. This part of the fundamental theorem is also called the integral evaluation theorem. Now, we've been playing with this a little bit throughout, but they're formally making it in there now. Any definite integral of any continuous function f can be calculated without taking limits, without calculating Riemann sums, and often without effort, so long as an antiderivative of f can be found. So we do a couple of examples here. So on this one here, they want you to do the antiderivative, evaluate this one. So we do the antiderivative, this guy here. So this is like a reminder of the power rule, that if you have u to the n, it becomes your antiderivative is u to the n plus 1 over n plus 1. Now this 3 is just a multiple, so you don't have to worry about him. So we have 3, and then our u to the n is x to the 2 plus 1, so 3, over your new exponent of 3, plus x. Because you need to know that 1 is the same as 1x to the 0 power. So 0 plus 1, 1. And evaluated from -1 to 3. Now remember, your limits of integration go a to b. So I may say -1 to 3, but you're going to really be doing it 3 to -1. By the way, this will clean up. And so we have x cubed plus x from -1 to 3. So we have 3 cubed plus 3 minus, so remember this is f of b, minus f of a, and a is the -1. So minus -1 cubed plus -1. So this gives us 27 plus 3 minus a -1 plus -1. So 30 minus a -2, 2 negatives make a positive, and we get 32. Now you guys can also grab a calculator, throw this into the calculator, and verify your answer. Okay, the antiderivatives, you got to remember that power rule. Right now we're going to do mostly power rules. You might see one for trig, you'll see some for trig, natural log. The ones that don't have properties like the product rule or quotient rule, you may not see those right away. Okay, so let's do another one. On this one here, we're going to rewrite this so we can do this one using the power rule. So this is still 0 to 1 of x squared plus x to the 1/2 dx. So this, if I integrate this, this gives me x cubed over 3. This is what I remind you. 2 plus 1 is 3, and then you divide by the new one. Plus, if I add 1 to this, this is going to give me x to the 3/2 over 3/2. That way from 0 to 1. Now, keep in mind, if you have 1 over 3 over 2, this is the same as 2 over 3. So we're going to rewrite this guy. So I have x cubed over 3 plus 2x to the 3/2 also over 3. Still evaluating 0 to 1. So I plug in 1, I get 1 over 3 plus 2 times 1 over 3 minus 0. Remember I told you guys you don't have to do the math, but if you know you're going to get 0, just write minus 0. I put 0 here, I get 0. I put 0 here, I get 0. 0. So in the end, we get 3 over 3 over 1. So the answer to this one is 1. And again, throw it in your calculator, double check that answer. Okay, next one, x cubed plus 1. Let's try that one again. Do keep in mind that once you do the integral, you don't write that again. So 3 plus 1 is 4, so this is x to the 4th over 4 plus x, evaluate from -1 to 3. So that gives me 3 to the 4th power over 4 plus 3 minus -1 to the 4th power over 4 plus a -1. So 3 to the 4th power is 81, so this is 81 over 4 plus, and I get a common denominator. That means I multiply top and bottom by 3 over 1 times 4 over 4. So this gives me 12 over 4 minus, this guy's going to go positive, so 1/4 minus 1, but 1 over 1 is the same as 4 over 4. And I'm doing this so I can quickly do my math. So 81 plus 12 is going to give me 93 over 4 minus, and this two together is going to give me -3/4. And two negatives make a positive. So that gives me 96 over 4, which is 24. So we get 24 for that answer. Okay, I had to pause it for a second. I was looking for another problem because there's only 3 examples, and I thought, oh, let's do one that might be just a little bit more difficult, like, a trig one. So let's try this one here. So 0 to pi over 4 of secant squared of x dx. And on these ones, these are the ones that you have to be able to recognize the trig function. So secant squared is the derivative of tangent. So this is just going to be tangent of x evaluated from 0 to 1. So this is tangent of x, I'm sorry, tangent of 1. Sorry. Let's pay attention to the problem I'm working on. So let me erase, not delete, erase this. When you see the answer, you'll know what I was doing. I have the answer in my head. I was writing out the answer. Tangent of pi over 4 minus tangent of 0. Well, tangent of pi over 4 is 1 minus, and the tangent of 0 is 0. 1 minus 0 gives us 0. Okay, now let's look at, what if I give you 0 to 1 and 1 over x dx. Now these are ones that, let's go a little bit more difficult kind of thing. Now 0 to 1, 1 over x dx, this you should recognize as being a natural log. So this would be the natural log of x evaluated from 0 to 1. So the natural log of x, I cannot put in 0 minus the natural log of 0. This is undefined, so I would have to put like anything. How about 0.1? 0.1. 0.1. We cannot put in you can't put in 0. The natural log of 0 is undefined. So that's why I said, oops, gotta fix that. And the natural log of 1 is 0, so this is 0 minus the natural log of 0.1, or negative natural log of 0.1. And without a calculator, that's as far as we can go. All right, so these are the kind of problems you'll see on there. And like I said, you'll have to be able to recognize them. And so like when I did the 0 to 1, I was thinking, oh, I can do tangent. I can do this one, 0 to 1 1 over 1 plus x squared dx. And you'll get different answers on this one because this is arctangent, so this is arctangent of x evaluated from 0 to 1. So I'm looking for the arctangent of 1 minus the arctangent of 0. Well, the arctangent, now usually they will give you on tangent, they'll give you a specific domain, sometimes, not always. And the reason I say this is because it's undefined in spots, and they don't want you going over the undefined spot. So we're looking at what angle has a tangent value of 1. That would be pi over 4 minus the angle has a tangent value of 0, which is 0. So this would give us an answer of pi over 4. This is what I mean on these. And some of them you just have to be able to recognize the derivative. This is why I've just been so harsh on you guys about knowing your derivatives. Because if you don't know your derivatives, it's going to be extremely difficult to do the integration. All right, this is where we're going to stop this video. So I'm going to just send you off with a good luck again.